I'm Elle Imhoff. I'm known across the internet as Chronic Death because I'm full of diseases. I got new ones, and they're not all autoimmune anymore, so cool. I'm a member of the Lumen core team, a principal software engineer at DockYard, and most importantly for this talk, the creator of the IntelliJ Elixir plugin. Oh, too many jumps. Okay. IntelliJ Elixir is a plugin for JetBrains IDEs. IntelliJ Community and Ultimate Edition, Community is free, of course, which supports any language, but it also works for those coming from Objective-C background using app code, C and C++ using CLine, SQL using DataGrip, Go using Golang, PHP using PHPStorm, Python using PyCharm, .NET using Rider, Ruby using RubyMine, or JS using WebStorm. In the almost 8 years since I started the project, I've released 87 updates, which averages out to 33 days between updates, with the last update only 9 days ago on June 1st. I originally considered starting plugin development after seeing Dave Thomas talk about Elixir at Lone Star Ruby, and it was only 2 days after the first ElixirConf that I did the first commit. I thought Elixir syntax is similar to Ruby's, as we all did back then. And RubyMine exists, so it can't be that hard to make an Elixir plugin. Unlike the other editors that use the Elixir language server, the IntelliJ Elixir plugin actually predates Elixir LS by 3 years. IntelliJ Elixir has a custom lexer using JFlex, a custom parser using GrammarKit, and uses the JetBrains Open API to deliver features you'd expect in JetBrains IDEs. This means that I'm writing Java and Kotlin to analyze Elixir. There turns out to be almost a third of the project in Elixir due to the extensive testing. Early in the project, my grammar and lexer were actually revealing bugs and inconsistencies in the lexer and parser in Elixir itself. The independent lexer and parser also means that code analysis works even if your code won't compile. Why is building on JetBrains Open API useful? You get cool features for free, like integration with Markdown support, when you use language to take code blocks. This working, I didn't do that. I didn't even know it worked. I just opened a README and it was working, and JetBrains just did it for me. So when writing your guides, syntax highlighting still works in code blocks. Parameter highlighting still works. Completion still works. Go to definition even works. As you can see the code block, repo is an alias. You as a human reading the code know that repo means your app's myapp.repo, but the code itself is invalid as repo isn't a top-level module. Ecto repo is, so why does the plugin find a result? It's again because of JetBrains Open API. Part of the resolving system in the API is that a result can be marked as valid or invalid. Invalid matches are a crucial concept in editors as you want completion and go to declaration to work while you're typing. The matching logic needs to handle whether the module matches, how well the name matches, which includes unknown names of derived function or when you're doing dot calls, whether the user is typing, and if a call is in the arity interval of the definition. I say arity interval and not arity range because special forms like with take an unlimited number of arguments, which for with is an interval from 1 to infinity. If there are no valid exact module matches, then IntelliJ Elixir uses the stub index to find any matches that match just the name or arity regardless of module. So we can navigate from Markdown even without the alias call because the indices built of the project let us find invalid matches with the same name and arity even if in the wrong module. If we go to the second entry, you'll see that what IntelliJ Elixir counts as a definition is more than just that which uses def or def macro. It resolves the callbacks too. IntelliJ Elixir has a ton of features that I've implemented in the past 8 years, but that's too much to talk about in the time we have here today. So let's cover what's new since the last time I spoke in February 2020, when the pandemic had started, but we weren't admitting it. It should be no problem. It's only 19 releases over 2 years, and we have less than 40 minutes. As hinted at in the explanation of go-to definition, IntelliJ Elixir finds as many definitions as it can that could be related to the current call. Version 11.5 extended that. With qualified calls, specs, aliases, module attributes, and variables with special support for @protocol and @for module attributes defined implicitly in protocols. Expanding support in the plugin reminds me a lot of how exploit development works. You find one bug in a system, and then you keep exploring around that area to find similar problems. Jose Valim has said that the debugger and IEX API are unsupported and not public, but that I can use it. So I do, but that does mean chasing after changes made to the internals. In Elixir 1.9.2, the Elixir URL record changed. Because records are just tuples and not maps, any change makes the code I run in the debugger break. So I need to change my version of it in the debug server. It's not guaranteed that the SDK shipped with the Erlang header files and not just the .beam files. So I can't depend on the same header files as Elixir itself. This is a difference between Homebrew, which is just beams, and ASDF that installs the source. Version 11.6 was released in the long, long ago of April 2020, so before Heeks was part of Elixir Live View, so leaks highlighting was added. How leaks and eeks works is once again based on JetBrains Open API, in this case support for template languages. The original eek support was a simple, small change. A lot of that change was regenerating the Elixir parser to support interleaving eeks template tags, but eeks as a language itself is really simple. This is the entire grammar. It's either data or tag. Leaks is the same since the actual syntax is not different, only the semantics and how it is compiled by Elixir itself. The data tag is then hooked up as template data element type and template data, which is used in getting the view provider element type. The view provider element type is then called to create the file, but only why does it know that the HTML.leaks file is HTML in addition to leaks? There's no support built into JetBrains for dual extensions. You can register one, but you have to do that manually. So how am I doing it dynamically? Well, that happens when the view provider is created. It calls template data language. There's a lot of stuff here about caching and fallbacks of the template language isn't known, but the actual logic of finding the template language from the file, let's focus on only template data file type, which is in the eeks file type. This function is making sure that there's only a single known file type. So let's see how it gets that set of types. In template data file type set, template data file type set finds the file type associated with the virtual file. In OpenAPI, they're called virtual files because what's in memory has to be synced to disk every once in a while, and it's kept in memory to be more efficient. So they're virtual files, not real files. Then gets those file types that have fixed extension and are removed from the path. And finally, checking if that new file name has a known file type. How would this work for real file? Say we have an index.html.eeks. It's an EEX file type, which has a .eex as extension. The code strips that extension off, leaving index.html, which matches the HTML language. So we get HTML support developed by JetBrains mixed with the eeks I developed, as you can see from the CSS selector breadcrumbs on the bottom of the slide. That's a JetBrains thing. I didn't make that. Because I don't hard code the support template languages, you can template stuff besides HTML, like SVG. It also means it works with language support from other plugins, say template Erlang source from the IntelliJ Erlang plugin using eeks, which would be weird, but doable. Version 11.8 was a great release because of all the features were implemented by community contributors and I didn't have to do anything. Quick documentation is the docs that pop up on hover when you're writing a call. You can trigger it with F1, but since not all of you are lucky enough to need a Kinesis Advantage 2, which has function keys for RSI like I do, you can also activate it from the menu by doing go to View Quick Documentation, and you'll get the docs you're used to seeing in hex docs. For XUnit gutter icons, the gutter icons are a single play button for individual tests and fast forward buttons per group like modules and describe. If you click on one of the icons, it'll run the module, describe, or test. The icons for groups or tests that pass will remain the same, but for tests that have errors, such as this test that is incorrectly checking for sign out message when it should be sign in, then the error is marked with an alert exclamation point behind the play button to rerun the test. Version 11.8.1 had graphical debugger fixes. The graphical debugger in IntelliJ Elixir doesn't communicate with the beam using a standard in, standard out pipe, but instead uses distributed Erlang with the IDE acting as one node. To make a Java node, the IDE needs to load the JInterface library. However, most package managers don't install JInterface, and by default, the Erlang build doesn't build JInterface. It's one of those things like SSL, XML, and doc support that it will just silently skip building if it can't find a dependency. As a former build engineer, I don't know why the make files for Erlang are just okay with missing dependencies. It annoys me to no end. So to be a good Java application, I had JInterface pulling them from the public Maven repository. Maven is like Hex, but for Java. JInterface doesn't get updated as often as Erlang itself because it only needs to change when the distributed Erlang protocol changes. In OGP 19, the protocol changed to support something called big creation. Big creation was future-proofing to allow changes to how PIDs, ports, and references were transmitted. It is part of the thing that prevents PIDs from seeming the same over distributed Erlang when the number is the same to you as a human reading it. So in the three numbers, the creation is one of those three numbers. The important part was that it was unused in OGP 19. So even though it's incompatible, and it existed since June 2016, it didn't actually break my usage of JInterface 1.6.1 until May 2020, when OGP 24 was out. It turns out JInterface wasn't being updated on Maven Central because the OGP team wasn't the publisher. Basho was, and they were just putting the OGP data in the package information since Basho only did the build and publish and not the actual production of the source code. Oh, but Basho fell over in 2017. Which explains why their publishing of JInterface stopped. So IntelliJ Elixir happened to start using the Maven Central repository just a few months before React fell over when Jake Becker converted the build from Ant to Gradle. I like to thank Jake Becker because he's also the contributor that first added the graphical debugger support to IntelliJ Elixir before moving on for all his work on Elixir LS. So the OTP team doesn't want it, and Basho can't do it. So I'm back to maintaining JInterface myself. I built it using OTP 24.0.3, and that's what's still being used to this day. In version 11.9, after only adding the documentation provider in the previous version, Marcin came back and improved the performance. The performance was improved by not calling mix in another process, but instead reading the .beam files directly using beam handling originally implemented for the decompiler. EAP48 is the standard that introduced the docs chunk to the beam format. For those not aware, Jose has done a lot to push the Beam and Erlang forward, and part of that is introducing new chunks that are helpful to everyone, like the ATU8 for Unicode atom support, so Jose can make his own name be an atom, and the docs chunk so that documentation can work across the ecosystem. The data is stored in a tuple. Remember, this is an Erlang enhancement proposal, so lowercase words are atoms, not variables, and title case words are variables, not module names. The metadata portion gives us some extra takes to apply to docs, like deprecate and since. The deprecate is then rendered as a separate section in quick documentation. Since the faster documentation provider had to read the docs chunk anyway, Marcin also added those docs to the decompiled code. In 11.9.2, there was even more decompiler enhancements. The addition of new features often lead to new bugs in old features due to new interactions. In the case of the quick documentation adding the docs to the decompiled code, it meant that errors in the docs could break parsing those decompiled files, which meant it couldn't resolve references to those modules. This affected the module, which is referenced by a lot of stuff. So the example doc in the module doc for module made all the modules, functions, and macros unparsable. Module. So why wasn't this a problem in the original source for module? Well, it uses the capital S sigil and triple single quotes to avoid needing to escape inner double quotes. The doc chunk doesn't preserve that outer sigil, though, because it's just a OTP binary with the string contents. Because everything has to understand it, not just Elixir. Erlang does, LFE does, Alpaca does, Gleam does. So what's the fix? We need to calculate a safe promoter and terminator. The promoter is the symbol at the start of a quote, while the terminator is the symbol at the ends of quotes. Sometimes they're the same, but sometimes it's matched curly braces. I got those terms from genetics because I couldn't think of the opposite of a terminator in computer science when writing the plugin. The safe promoter and terminator calculates the safe promoter by checking for either single or triple double quotes. If it has both, nothing is safe. But if it only has one, then the other is safe. If it has neither, it just defaults to triple double quotes. With the safe promoter found, or no safe promoter terminator at all, we use that to choose the outer promoter terminator. Then we use safe promoter terminator to reformat the original text when appending. Only when we don't have a safe promoter or terminator do we actually need to reformat the documentation text to escape the existing triple double quotes, which fixes the docs and the parsing and the references. If it's not clear from that, the decompiler exists in IntelliJ Erlang and the Beam support because I don't hard code how the standard library works. I parse it just like it's your own source code. So the decompiling stuff has to work for the completion and go to references for standard library to work. Tomoki Odaka, longtime excellent bug reporter and sponsor of the project, noticed that sometimes the highlighting would just give up while typing invalid code that was then fixed. You want to know how good of a bug reporter Tomoki is? Tomoki links to similar bugs, gives reproduction steps and screenshots, but wait, that's not just a picture. That screenshot is a movie. So even though the map on line 3 gets highlighted correctly, line 2 never recovers. Part of the reason I originally picked using JetBrains lexing and parsing libraries instead of using Elixir directly is that it has automatic error recovery. The parser will automatically shift the lexing around an error, but there's a hesitation and the user can see the lexer and parser take time to recover, which is unexpected. You can see the editor still thinks the code is messed up and the red squiggle, even though the code is valid, and it triggers an error report, and then the squiggle goes away and it reparses the whole file for some reason. So why that delay where it thinks there's still an error in the code? It turns out that there are some unwritten rules about how the parser uses the lexer. If the lexer is in its initial state, then it's okay to only rewind the lexer to that point in the file. That stops you from having to reparse an entire file when you're editing code in the middle of it. It makes a much faster editor experience. Good solution to that problem. So why does that cause a problem? Well, whenever there's an open curly braces encounter, this might be interpolation. But we don't want a closing curly brace to close an interpolation. It's actually closing a tuple. When in the initial state, called YYInitial by JFlex, the closing curly brace needs to count as just a closing curly brace for a tuple or map. But when in the interpolation state, it needs to count as the end of interpolation. So if we look, when we're in the middle of interpolation, we're in YYInitial again. So when we combine that with the assumption that OpenAPI makes that YYInitial is okay to resume from, we resume from the middle of the interpolation when there is an error. What's the problem with resuming from there? The reset function doesn't restore the stack, which means this stack is missing. Why is Elixir not restoring its own stack? Well, I kind of add the stack to make it work for interpolation. Since the Elixir lexer is written as Erlang functions, it can be a full Turing machine, but Flex can't. Flex is able to generate a very efficient grammar by translating regular expressions, not extended regular expressions, not the ones we use, not what we think of regular expressions, but like the mathematical computer science regular expressions, to a finite automaton. So that a finite automaton lacks one important feature needed for Elixir. It cannot track infinite recursion of the language. Elixir requires this because you can nest expressions inside of interpolation, including a string or careless, which supports interpolation. Although it is unlikely to happen in actual code for readability reasons, I didn't want to make the editor's grammar more strict than the real grammar, as I believe editor grammars need to keep working while you're typing and writing bad code. Flex thankfully has an escape hatch. Because arbitrary Java code can be run on each regular expression match, the Java code can keep track of a stack, which elevates the computation model from a finite automaton to a pushdown automaton. It's called pushdown because you're just pushing on the stack. The name makes sense. A pushdown automaton is the minimal complexity needed to track anything that requires balanced nesting like parentheses or interpolation braces. Now, the lexers were equivalent for handling interpolation. So the lexer needed a fix. There were 3 ways the bug was fixed and prevented from happening again. The problem was always counting nested braces, even if it didn't affect interpolation. At the lexer level, you want to just say that this piece of text is a token whenever you can. It is the parser above the lexer that does the matching and matches do to end to make a real call. The lexer should not be doing this if it can be at all avoided. So for YYInitial, the lexer no longer adds to the stack. For interpolation, we enter a new state. Interpolation curly. In interpolation curly, it recursively adds to the stack for each opening curly brace, but we pop each from the stack on matching closing curly until we finally get back into interpolation. The next part of the fix was to not re-enter YY initial with a stack. So if push and begin is ever called with YY initial, throw an exception. And also if the stack itself is ever pushed another YY initial when it isn't empty. The third part of the fix is to clear the stack on reset. I could easily lose this crucial line when making Elixir updates in the future though, because that part cannot be templated in JFlex. So I have to have tests that yell at me to add the code back in. After finding a 6-year-old bug, version 11.10 was much more chill. It only involved expanding support for newer versions of OTP and SDKs and porting the Credo inspection to work with Dialyzer too. IntelliJ Elixir doesn't just have a decompiler, but also a disassembler. When OTP adds new opcodes, I need to explicitly add support for them to the disassembler because the binary format does not include the expected argument count. That would take much more space. But the disassembler can protect from incorrect disassembly because the code chunk includes max opcodes used in the data. This format is actually smaller than Erlang external term format. It is a specialized format just for code. I've talked about it previous years. Once I know beam opcodes are missing, it's easy to find them because no opcode is ever removed, and all the opcodes are in the ops tab file. In Beam itself, this tab file is transformed with Perl to make C code for the VM. So we're all using Perl. When adding the opcodes to the disassembler, the important part is the number of arguments. But since in the code chunk, the arguments are just numbers, it can be useful to specialize the disassembly to make the disassembler show more human-readable values like fail labels. Fail labels is an argument that should inline labels. Options supports treating arguments as labels, but also atoms, functions, integers, lines, literals, local calls, and strings, which all reference other places in the Beam file. When we combine all these options, the disassembler can toggle the inlining on and off. Here's how that looks in the actual disassembler. I have a Beam file open in the editor, and I went to the Chunks tab before going to the code chunk. If I turn off all the inlining, you get the bare binary format syntax without any semantics. Adding a new package manager's SDK has two parts in IntelliJ Elixir: knowing where to look for it, and the priority it should have compared to other installed package managers. This priority is necessary because at times for different clients, I've had both Homebrew and ASDF installed at the same time. I've also had Nix installed, which is weirder. This order mostly comes down to what is convenient on client projects, but feel free to open PRs, placing your favorite package manager in the prime location. If you don't like the suggested directories, you can pick your own or use one of the other suggestions when you go to Preferences, Project Structure, Platform Settings, SDK, and click Plus, and they appear at the bottom down there. Dialyzer inspection support was a community submission. In order to run Dialyzer, you need DiaElixir or another project that supplies the Dialyzer mix task in your project. Then go to Code, Analyze Code, Run Inspection by Name, and type Dialyzer to find the inspection. Importantly, make sure to select the one for Elixir if you also have the IntelliJ Erlang plugin installed, because it will not understand your Elixir code, and it'll also give you the Erlang-style Dialyzer output instead of the Elixirified output that DiaElixir gives you. Since Elixir has more than one package for running Dialyzer, if your package doesn't call the mix task Dialyzer, which is the case with the one that isn't called DiaElixir, I think the one called Dialyzer, the mix task, isn't actually called Dialyzer. It might be called Dialyze. It's confusing. You can customize the arguments in Preferences, Editor, Inspections, Dialyzer. Version 11.11 started users reporting weird changes in go-to-definition in JetBrains IDEs 2020.2 IDEs. It broke multiple dynamic languages, including Bash, Clojure, and my own Elixir, and I took that personally. So not only did I work around the break, I also vastly improved the reference resolution because there's no engineering like over-engineering. So now each alias in a qualified alias can resolve separately. So one thing to realize about Elixir syntax is while we as humans use the dot in the module name to mean nesting, that's not a thing on the Beam. The Beam files all have flat names. So the fact that I support this is very much me as a human, I want it to work this way, not how the language works. Previously, completions for aliases used the larger all-name index, which is slower because it contains function stuff and specs and callbacks, than using the smaller module name index it does now. That modular name index was first added for when you hit Shift or you go to, for which control it is, to search by class name. That was the original reason for the index. And now this is extending it to using it everywhere else that makes sense. In monorepos, and the reason for that is the all-name index in most projects is 90,000 entries. That's like all the number of modules and function names that you have in your project normally. In monorepos and Poncho projects, there can be multiple independent libraries and sources for each IntelliJ module. So this is IntelliJ's concept of module and projects, not an Elixir module, to be clear. So like a module would be, if you did Phoenix with an umbrella, the backend would be one module. So it's like everything where there's a mix, that EXS is the way to think of what is an IntelliJ module. If you want to find aliases completions in web, we don't want hardware modules being given as options. But before 11.11, all project was used to search the scope, which would pull in everything. But instead, in 11.11, the completions are scoped to just web and actual depths with the very concisely named module with dependencies and library scope. In the past, users have said they prefer not to see both source and decompiled results. So in 11.11, preference is given to better results unless no results would be shown. This is a pre-filtering of invalid results if you have valid results, things in the same module if it's close, but you have another function in another module with the same name, or source over decompiled results. Version 11.11 was released in June 2021, and Phoenix was still using leaks instead of Heeks. Heeks support came out with Phoenix 16 in the next month, I think. So projects I had access to had leaks that I could use to vastly improve the resolving. So change set is used in form templates. It is found in 3 spots. In the second case, you can see that as resolving to a key, but the variable name is final change set, so it really is checking the key and not the variable name. Then the third change set is resolving as an argument to assign 3. At myself isn't defined in a macro and instead buried in the library. So Elixir, I wanted it to find it there, so I made it do it. At socket in the template is resolved to the socket and handle params. In the generated code for Phoenix endpoint, the code reloading is used to configure the code reloading socket. It's resolved with the var_bang declaration in the library code. After leaks, the next big library for reference improvements was Ecto. Ecto's macros are super weird, and most of the words and variables aren't real functions or variables. For Ecto query, the p declared in a from in can be resolved to a select. The bindings in a functional join, where, group by, order by, having, select, distinct, all works. Ecto query API is a house of lies. The definition and the actual modules are just there to allow documentation. If you import the module directly and try to use it directly, it will raise an error, but its lies do not matter. IntelliJ Elixir will also resolve binding references in those calls. For Ecto schema, field can be resolved to either import or the macro definition. You're probably thinking, what's so impressive about that? Field is just a macro. Well, how field works in schema is use Ecto schema calls, Ecto schema using, which imports Ecto schema. But that's only importing the outer schema DSL. Where is field coming from? When you do schema do, it calls the schema macro, which calls the schema function. It contains a large quote block that is stored in the preload variable, not directly returned. At the end of the preload block is a try block. Aha, there's the import Ecto schema. But preload is just a floating quote block. How does it get out? At the end of the function is a quote block that is returned and unquotes the preload quote block. So to statically analyze an Ecto schema module, there are only these 9 simple steps. Making type resolution was impeded by built-in types not having a shared definition. So I fixed that by decompiling fake types in Erlang.beam. They have to be fake because in actual Erlang, like it's just a thing the compiler knows, because any definition would just give the value again. It'd be a stupid definition. And so find usages works on built-in types. Here I can find all usages of the map type. I was able to find and fix or improve so many reference resolutions because I made an inspection that tells me any alias or call that does not resolve, except ones where it looks like a potential key or field access because I wasn't prepared to implement chained resolution like that yet. Why I was able to resolve and assign to a map key and Ecto references to binding is, unlike the compiler and ElixirLS built on top of it, the resolutions of variables, assigns, calls, and aliases customizable for the editor. So it doesn't have to follow how code is really compiled, and instead is whatever leads you to better understanding of complex libraries, including related items like map keys buried deep in other libraries or other modules in your own code. That's what an editor should do, and that's what it does do. Version 11.12's change were all powered by testing against the Yocto library that Tomoki Odaka was using. A full open source reproduction library unlocks so many inputs when combined with the Elixir references inspection. Yocto is a wrapper around Ecto that automatically generates migrations. To do this, it wraps the schema and field DSLs. Similar to Ecto, when use Yocto schema is called, it only imports the outer schema call. When schema is called, it captures the calling block and unquotes it after importing Yocto schema. So to support this calling convention, if a macro has a do keyword argument, grab the first call in the body if it's a quote. Then if that quote block has an unquote that is the argument to the do keyword, then search backwards as if those previous siblings were directly in the block. IntelliJ Elixir 12 answers the question, what if I spent 6 months making everything, I mean everything, in Ecto resolve? I chose Ecto after how effective using Yocto was for version 11.11. Using the Elixir references inspection, the number of unresolvable or invalid references dropped from 496 to only 28. This was all accomplished with only a few minor changes. Version 12.1 added Elixir 1.12 syntax changes. Yeah, that's a number flip. Sigil colors and decompiler enhancements. Elixir 1.12 added new operators to the syntax. These are things that came from the work on NX, including the power operator and step ranges, which required updates to IntelliJ Elixir's Lexer and parser. With the introduction of more sigils that are common in the ecosystem like E, H, and L, allowing each sigil to have its own color became crucial. You can go to Editor, Color Scheme, Elixir to customize the color scheme in general, and the textual sigil and the specific letter to customize the specific sigil from there. Both the light theme and the far superior dark yellow theme had the colors of each sigil equally distributed around the hue wheel in the HSB color coding, so they're spaced about 14 degrees apart so that there's still good contrast, even with 26 colors. Version 12.1 contains decompiler enhancements. In the previous versions of the decompiler, guards weren't being decompiled, which led to function clauses that seemed to conflict with each other. But now the guards are decompiled, which makes the decompiled code much easier to understand and more accurate. Lists in the debug chunk look like a call to a pipe function, and the decompiler used to decompile it as such. The fix is to recognize this as a real function and decompile it as an improper list. The decompiler is based on a port of the Elixir macro to string to Kotlin. In parts of it, it defers to inspect, which was also port, which led to inspecting external function captures, which uses the comment tag to indicate it's not valid code. But that breaks the decompiled code because that comment hash is uncommenting the end of the function call and the do. Version 12.2.1 improved performance by delaying decompilation when resolving references and find usages. Previously, .beam files were decompiled and then processed as if they were source. But that led to freezes when having to decompile large modules like kernel, kernel special forms, and the Unicode module. The Unicode module, when completely decompiled, is 160,000 lines long. It is so large that the JetBrains API is just like, nah, and reports it as a plain text file. So like I was getting bugs that like the Elixir plugin was like, this .beam file is plain text. And I'm like, you know it's Elixir, you're the plugin, and that's why. Eventually, the JetBrains plugins just give up. It is a setting you can change that I've had to change for like Rust and Go, so you can make it go farther, but don't make it so long that Unicode works. Version 13 added support for 2022.1 JetBrains IDEs. Version 13.1 added support for more integrations with Mix. JetBrains added an experimental extension point for external formatters. IntelliJ Elixir already had a configurable formatter that predates Mix format. That internal formatter is still used for indenting new lines and formatting selections in a file, but at the file level or above, Mix format is used. The formatter does not run automatically. If you want to run automatically and save, you'll need to turn on by going to Preferences, then Tools and Actions, and you'll need to check Reformat Code. If you're one of the holdouts that doesn't like Mix format, Chris McCord, and wants to give me work to do when I fix your project to follow community standards, you can disable Mix format and continue to use the more configurable internal formatter. Go to Preferences, then Editor Code Style Elixir. On the first tab, Mix Format, and then uncheck Format Files with Mix Format. In 2022 IDEs, JetBrains changed how new project works for custom code modules, which had the side effect of hiding Elixir from the new project menu. Actually, after I wrote this talk, they said that was a bug. So this is, again, I'm working around a bug in their code. I worked around this by using the new Project Wizard language extension point to add Elixir to the language list, the same as JetBrains support language like Java and Kotlin. Since having to work around JetBrains regression annoyed me, I made this version better by calling mix new and adding all the command line options to be overridden instead of generating a project from a template. It calls mix new in the background using the selected SDK. The previous iteration of the Credo integration was fragile and non-performant, so it's been rewritten as a batch inspection only. In order to run it, you need Credo installed on your project, then go to Code, Analyze Code, Run Inspection by Name, and type Credo, similar to how Dialyzer works. Click through to run the inspection. The Problems tool window will open where you can click through the problems identified by Credo. Environmental variables for XUnit and eSpec run configurators are used when debugging them. The debugger server now supports Elixir 1.13. The changes are due to differences in how variables are declared in the translated Elixir to Erlang code, and how variables are tracked in the Elixir env struct. If you have any questions, you can contact me by email or on Twitter or Elixir line Slack as @chronicdeath. If you'd like to support my work on the plugin, you can support me directly through GitHub sponsors. If you're interested in working with me, you can contact DockYard with a hire link, or email me directly and I'll get you in touch with our sales department. Working with me through DockYard means I can get IntelliJ Elixir working on your exact project and work on it during business hours too. If you're interested in IntelliJ Elixir, you can download IntelliJ Community Edition for free. Plugin install happens inside the IDE, but you can also view plugins in the JetBrains plugin repository, and the source for the plugin is available on GitHub. Yeah?
So I don't have this mic, so I have to come here. I think we have time for one question. There are two on anyone here wants to ask a question? Okay, I'm gonna just ask one, and then the other one maybe you can answer later. So, despite your incredible contributions, let's go. IntelliJ support for Elixir still feels less robust, full-fledged than VS Code. What is the biggest barrier to achieving parity, and how can we help?
Mostly time. Like I said, hire me through DockYard so I can just work on the plugin. Like, this is, like I work on this in my spare time. DockYard is nice enough, unlike most companies, that we get DockYard Fridays to work on it. That's 8 hours a week. But these features take multiple full-time weeks. And so a thing that takes a week to do takes a month or more to do. And so it's a matter of time. But community contributions are done. People don't want to do it because it'd be writing Kotlin, but at the same time, I don't write a VS Code plugin because I don't want to write JavaScript.
Thank you.